Hi folks, welcome back to Calculus with Mr. Robeson. All right, today we're looking at section 2.5, explicit versus implicit forms. So we're going to look at a new form of equations here. We're going to look at implicit differentiation, and we're going to do some examples of implicit differentiation. It's not as hard as it sounds. All right, so what we're used to is this explicit form right here when we can get y equals something in terms of x. So all the x guys, all of our variables are over here except for our 1y on the other side, y equals. This is called the explicit form. All right, this is when we've been taking derivatives. We can take derivatives here pretty easily. Like the derivative of 3x squared is just going to be 6x, and the derivative of 5 is gone. And we can say that this is either dy dx or y prime. Either one's fine. There's our answer. Very quick, very easy. All right, over here, this is what we call the implicit form. So we have x times y equals 1. So it's not solved for y. All right, it's not in the form y equals. All right, we probably could solve this for y if we wanted to. We just divide both sides by x. But sometimes that's not so easy to do. Like when we move down here, when we got a y cubed here and a y to the first here, not so easy to solve that for y. So these are called implicit equations or implicit forms. But we can also take their derivatives in a new, somewhat different way. All right, so how do we do implicit differentiation? So if we can solve for y, then do that. If you can solve for y, then do that. Take the derivative. If you can't solve for y, then we have to differentiate implicitly. So implicitly means when we're differentiating, whenever we take the derivative of y, we take the derivative of it normally, but then we add a dy dx, or we can add a y prime if we want to write something a little smaller. Just make sure it's not y to the first. All right, so again, whenever you're taking the derivative of y, it's a chain rule. Remember, everything's a chain rule. All right, so here we want the derivative of x to the third. X is our variable. So it's just normal. Derivative of x to the third is 3x squared. Technically, it's times dx over dx. We usually just don't write that because this is just 1. So we just get 3x squared. All right, now when we do the same thing with y here, with x as our variable, we remember that y is some sort of function of x. So we take its derivative, we get 3y squared, and we have to do a chain rule. So times the derivative of y, which is dy dx. We can leave it like that, or we can write it as 3y squared times y prime, like that. All right, so that is the difference now when we're taking the derivative of y, we have a dy dx. Right here, we've got a guy with x and a guy with y. All right, the guy with x, it's just normal. Derivative of x is 1. Derivative of 3y is going to be 3, and the derivative of y is dy dx. So we can write that like that. Or you could write this with a y prime instead. Here, we're multiplying these two guys together, so we have to do a product rule. All right, because y is some function of x, so we have to treat it as something with x's. So it's something with x's times something else with x's. So the product rule says first times the derivative of second. So that's going to be 2y times dy dx, chain rule, plus the second times derivative of the first. Derivative of x is just 1. So there's our derivative. Usually we'll clean this up and we'd say that this is 2xy times dy dx or y prime plus 1 times y squared is just y squared, like that. And there's our answer. All right, so here's an example. Go ahead and pause it. Give it a try. All right, so when we take the derivative of the x guy here, the 2x to the third, that's just normal. We bring down the 3. 2 times 3 is 6. X to the 1 less exponent is squared. Minus, we still got a 5 out front. That doesn't change anything. Derivative of y squared is 2y to the first times dy dx. All right, so 5 times 2 is 10, so we can say that this is 6x squared minus 10y times dy dx. All right, and that is an answer choice there. That actually is answer choice A. So hopefully you got A. All right, so now we're going to put it all together into an actual equation. So now we've got an implicit equation here. Before we were just practicing taking derivative. So here's our step-by-step process. So I'm calling it step 0 because it's not often that we can do this if it's in this form. But step 0 is solve for y. If possible, we can solve for y and take the derivative, we've got y's here, we got y's here, we got y's here. It's not going to be easy to solve for y. So step 0 is kind of out of the picture here. Step 1, differentiate both sides of the equation with respect to x. So this is just like we were doing before. We just want to take derivatives here. Derivative of 3, or y to the third, is going to be 3y squared times dy dx. Plus derivative of y squared is going to be 2y to the first times dy dx. Minus, we've got 5y, so that's 5. Derivative of y is dy dx. Minus the derivative of x squared is 2x. Equals derivative of negative 4 is 0. So there is step 1. Step 2. Collect all terms containing dy dx on one side of the equation and all other terms to the other side. So this has dy dx, this has dy dx, this has dy dx, this needs to move to the other side. So we're just going to add 2x over there. So we'll get 3y squared dy dx plus 2y dy dx minus 5 dy dx equals 2x. So that's step 2 done. Step 3, factor out dy dx. So by design, everybody over here has this dy dx, so we can factor it out. So we bring out the dy dx, and that will leave us with 3y squared from the first guy, 2y from the second guy, minus 5 from the other guy, equals the 2x over there still. All right, hopefully you're starting to see the finish line here. So we factored it out, and now our last step is to solve for dy dx. So we just have to divide this guy away. It's always just going to be dividing that off. So we get dy dx equals the 2x over all of this guy. So 3y squared plus 2y minus 5. And there's our answer. Now, oftentimes we feel like it's not right if we have y in our answer, but here that's perfectly fine. Y was in our equation to start with, y is going to be in our answer too. All right, so we are solved for dy dx. We got it by itself. There's our answer. If you're curious, that's what the graph of this guy looks like. All sorts of weird shapes happen when we have x's and y's put together. All right, it's not a function, as you can see. We would not pass the vertical line test. If we drew the vertical line right here, it would cross it there, there, there. So it's not a function. All right, so that means we couldn't solve it for y. All right, but it still has a slope. So it's still like here would still have some sort of a slope. Here would have some sort of slope of the tangent line. Here would have some sort of slope. Here would looks like it'd be a slope of 0. So we could still calculate the slope at all these different places if we wanted to. All right, so now you guys try one. Go ahead and pause it and give it a shot. All right, so if I were to do this one, let's say the derivative of 3y is 3 dy dx, because derivative of y is just dy dx, the 3 stays. Derivative of 3x is just 3, derivative of x is 1, so 3 times 1 is just 3. Minus y squared is going to be 2y times dy dx. Minus derivative of x squared is just going to be 2x, technically times dx, but we don't have to put that. Equals derivative of negative 20 is 0. All right, so that was step 1. Step 2, we want everything that has dy dx on one side, and everything else is going to move to the other side. So we're going to subtract 3, and we're going to add 2x. So we're going to get 2x minus 3 over here. And over here we've got 3 dy dx minus 2y dy dx. Next up, we've got everybody over here has a dy dx, so we can factor it out. We're left with 3 minus 2y equals 2x minus 3. And then finally, we just have to divide this over. So we get dy dx. Our derivative is 2x minus 3 over 3 minus 2y. And that is answer choice B. Yep, there it is. All right, and remember, if we really get tired of writing dy dx, we can write this as y prime. All right, I might do that on this one just for an example. So take the derivative of this guy implicitly. All right, so it's a little tougher, just a little warning. We've got some sort of product rule happening here because we have something with x times something times y. But go ahead and stop it. Try and do it. All right, so first, there's no way we could solve for y here because there's too many y's all over the place. We could put some stuff together if we really wanted to. That may make our lives a little easier. So I'm going to actually try and do that first. So I'm going to subtract x squared from both sides. And I'm going to subtract, I'm going to go ahead and just add y squared to both sides. Could have also subtracted. So now those will cancel out. Those will cancel out. So we get 3xy plus 2y squared equals 2 of them minus 1 of them, so we get 1x squared. Notice I have not taken any derivatives yet. I'm just moving terms around to try and make it smaller. All right, so now I'm going to take derivatives. So when I do that, I'm going to treat this as my first and this as my second. So 3x times y. And just put the 3 with the x. So it's first times derivative of the second, derivative of y. Instead of writing do y dx every time, I'm just going to write y prime this time. Plus the second times derivative of the first, derivative of 3x is 3. Plus this derivative of 2y squared, we bring down the 2, we're going to get 4y to the first times derivative of y, which is y prime. Derivative of x squared over here, so it equals 2x. So we've got a dy dx or y prime there, and another one there. That means this guy, this 3y, needs to move over. So we get 3x times y prime plus 4y times y prime equals 2x minus, and this was 3y, so minus 3y. All right, so now we've got y primes here and here. We can factor that out. We're left with 3x plus 4y equals 2x minus 3y. Some of you will get quick at this and you'll start to notice, you know what, I can just go ahead and factor out the y prime. Once you're moving this guy over in your head and you just factor out the y prime, so you can go straight from this step to this step if you want. That's okay, as long as you know what you're doing. And then y prime equals 2x minus 3y over 3x plus 4y. And remember, y prime is the same thing as dy dx. And yep, that matches what we got. All right. All right, so that's how we do implicit differentiation, and those with some basic examples there. We'll come back next time with some tougher examples. We'll add in some trig stuff and things like that, and we'll find some tangent lines. All right, so I'll see you then.